Hello everyone, welcome to this video of
Enlarge hole and increase internal dia.
Drilling is a cutting process that involves cutting a circular shape hole of definite diameters in workpieces by using a multi-point cutting tool called a drill. The drill bit used in drilling is a type of rotary cutting tool that rotates while subsequently scraping material out of the workpiece. Now, in this video, let us see the different parts of a drill bit, different drill angles, and a job sequence that shows how to enlarge the internal diameter of a drilled hole.
Drilling is the first operation done internally for any further operations. For this, the drill is rotated with a downward pressure causing the tool to penetrate into the material. The various parts of a drill can be identified as point. The cone-shaped end which does the cutting is called the point. It consists of a dead center, lip or cutting edges and a heel. Shank. This is the driving end of the drill which is fitted onto the machine. Tang. This is a part of the taper shank drill which fits into the slot of the drilling machine spindle. Body. The portion between the point and the shank is called the body of a drill. The parts of the body are flute, land or margin, body clearance and web. Flutes are the spiral grooves which run to the length of the drill. Land or margin. The land or margin is the narrow strip which extends to the entire length of the flutes. The diameter of the drill is measured across the land or margin. Body clearance. Body clearance is the part of the body which is reduced in diameter to cut down the friction between the drill and the hole being drilled. Web. Web is the metal column which separates the flutes. It gradually increases in thickness towards the shank. Like all cutting tools, the drills are provided with certain angles for efficiency in drilling. There are different angles for different purposes. Point angle or cutting angle. The point angle of a general purpose standard drill is 118 degrees. This is the angle between the cutting edges, lips. The angle varies according to the hardness of the material to be drilled. Helix angle. Twist drill is made with different helix angles. The helix angle determines the rake angle at the cutting edge of the twist drill. The helix angles vary according to the material being drilled. According to Indian standards, 3 types of drills are used for drilling various materials. Type N for normal low carbon steel. Type H for hard and tenacious materials. Type S for soft and tough materials. The type of drill used for general purpose drilling work is type N. Rake angle. Rake angle is the angle of flute helix angle. Clearance angle. The clearance angle is meant to prevent the friction of the tool behind the cutting edge. This will help in the penetration of the cutting edges into the material. If the clearance angle is too much, the cutting edges will be weak, and if it is too small, the drill will not cut. For drilling holes on materials, the drills are to be held accurately and rigidly on the machines. The common drill holding devices are drill chucks, sleeves, and sockets. Drill chucks. Straight shank drills are held in drill chuck. For fixing and removing drills, the chucks are provided either with a pinion and key or a knurled ring. The drill chucks are held on the machine spindle by means of an arbor fitted on the drill chuck. Taper sleeves and sockets. Taper shank drills have a Morse taper. Sleeves and sockets are made with the same taper so that the taper shank of the drill, when engaged, will give a good wedging action. Due to this reason, Morse tapers are called self-holding tapers. The drills are provided with 5 different sizes of Morse tapers and are numbered from MT1 to MT5. While fixing the drill in a socket or sleeve, the tang portion should align in the slot. This will facilitate the removal of the drill or sleeve from the machine spindle. Use a drift to remove drills and sockets from the machine spindle. While removing the drill from the sockets or sleeves, don't allow it to fall on the table or jobs. After understanding about drilling, let us now learn the procedure to enlarge or increase the internal diameter of a drilled hole. Check the raw material for its size. File and finish to size 80 by 63 by 9 mm and maintaining parallelism and perpendicularity. Apply marking media. Mark off center lines and locate the center of drill hole as per drawing. Punch on the intersecting lines using prick punch 30 degrees. Set 12.5 mm in divider using steel rule and draw 25 mm diameter circle. Punch the 25 mm diameter circle using prick punch as shown. Fix the job on the drilling machine table. Fix center drill in drill chuck and locate the drill hole in center of the workpiece. Fix diameter 6 mm drill in drilling machine and drill pilot hole in the center drilled hole. Set the drilling machine speed according to the diameter of drill. Similarly, fix different diameters drills of 10 mm, 16 mm and 20 mm one by one in drilling machine and enlarge the previously drilled holes. Finally, enlarge the previously drilled hole to 25 mm diameter by filing as shown. Finish filing of the job and deburr in all the corners. Apply a thin coat of oil and preserve it for evaluation.
In this video, we have learned the drilling process and the different parts and angles of the drill bit. To enlarge a drilled hole on the drilling machine using different diameter drills. Preserving workpiece with lubricant for evaluation. Thank you for watching.